Hi everyone, thanks for being here today. I am here to talk about 6PPD Quinone and how some of us on the West Coast have been responding to an emerging contaminant. I am someone who's worked in the stormwater field for over 20 years in Washington State, and I recently joined Jacobs Engineering. I've been with Jacobs for about 3 years. And I'm a stormwater retrofits project manager. And prior to joining Jacobs, I was with WashDOT for over 17 years in their stormwater program. So I have been tracking 6PPD since the initial research was kind of being rolled out, and been actively involved in kind of the response related to permitting associated with 6PPD. So I'm going to ask a special guest, Jeff Dreyer from WashDOT Fish and Wildlife Program, to come up at the very end of my presentation to talk real briefly about how WashDOT is adjusting and responding to this emerging contaminant as well. So first off, I'm going to start with what is 6PPDQ, why is it a problem, and what can we do about it? Then I'm going to talk about the changes in the regulatory process in Washington State and the Pacific Northwest related to 6PPDQ, and then talk briefly about what you can do to address this emerging contaminant in light of the fact that the science is constantly evolving. But first, I'm going to give a little background for those of you that may not know anything about 6PPDQ. It all started back in the early 1980s in urban Seattle streams, where coho salmon were found dead, full of eggs, which is not normal. They termed this condition pre-spawn mortality or urban runoff mortality syndrome. And this is a very important problem in the Pacific Northwest because coho and salmon are iconic. So there was a pretty immediate response to start looking into what is the cause of this toxic event that's occurring and killing coho. So research was done for 40 years trying to figure out what is the cause. They looked at the common, metals, copper, couldn't figure it out, but they knew it was something coming from stormwater. That led them to start looking at what is coming off of cars, and specifically they were looking at tires. They took tires, ground them down, and created a leachate, and they were able to, in the lab, recreate that toxicity when they swam coho in that tire leachate water. They then kind of fractionated that tire leachate water to come up with the causal agent for the toxicity to coho salmon. They identified 6PPD Quinone as the toxic pollutant. So I just boiled down like 40 years of very complicated science into like a minute. So if any of you are stormwater geeks like I am, and you are like, how did they figure that out? Please feel free to come up afterwards, and I can share with you how they came to that important conclusion. But 6PPDQ is the problem. So what is it, and where does it come from? It's a chemical that's been added to tires since the 1960s to prevent the tires from cracking and improve safety. When 6PPD merges to the edge of the tire, it comes in contact with ozone, and it creates 6PPD quinone. So it's a transformation product of 6PPD. Researchers are saying that 6PPDQ is one of the most toxic chemicals ever identified. Coho die rapidly when exposed, and they are not able to survive even if stormwater is mixed with 95% clean water. So it's very toxic at very low concentrations. Fish that have been exposed, that are moved into clean water, don't recover. There are additional species that have been researched to find out, how is this affecting other fish species, as well as macroinvertebrates and things like that, but I'm focusing mainly on fish impairments here. So you can see that they've found that other fish species like steelhead, rainbow trout, brook trout are also sensitive to 6-PPDQ, though none of them are as sensitive as coho. And as we speak, there are more studies underway to identify additional species that are affected by this pollutant. And a lot of people wonder, is this just a Pacific Northwest problem? And the answer is no. As you can see from this map, this is just 4 different species of fish. And as additional research is completed identifying species that are also affected, potential is this map is going to grow. There's going to be full coverage potentially of the United States. So it's not just a Pacific Northwest issue. So now shifting to what can we do about it? There were some early studies in 2015 and 2016 that found that filtering highway runoff through bioretention soil mix reduced the toxicity to coho and kept them alive. And researchers thought that the toxicant had to be bound to organic matter. However, that original bioretention soil media that they were using, which was 60% sand, 40% compost, also tends to export phosphorus and metals, which is a problem. And you can't really use that in areas where there's a phosphorus or a nutrient impairment. So Ecology, the regulator in Washington State, started funding some studies to look at what they call high-performance bioretention soil mixes. And there's a link here to that document that they created summarizing some findings. But essentially they were looking for other combinations of media that could provide treatment and not create that export of phosphorus and metals. A recent study, just I think published in the last month or so by King County in Washington State, found that a media composed of 70% sand, 20% coconut coir or fiber, and 10% biochar with a polishing layer on top of sand, iron, and aluminum provides 96% removal of 6-PPD quinone. Often the effluent did not contain any detectable levels of 6-PPDQ, and it also does not export phosphorus and metals like the previous bioretention soil mix. So it is a good option in phosphorus or nutrient impaired areas. Ecology also, right when this research was published identifying 6-PPDQ, Ecology hired some consultants to look at commonly used BMPs across the nation and evaluate their effectiveness in removing and reducing 6-PPDQ. They looked at how those BMPs work to remove pollutants and the physiochemical properties of what we knew about 6-PPD and 6-PPDQ at the time. They were able to complete a report in 2022 that identifies high potential treatment and flow control BMPs. Those being dispersion, infiltration, bioretention or bioinfiltration, and generally BMPs that provide treatment through sorption. And you can actually, I have a reference at the end of this slide deck that has a citation to that report, and you can see all of the BMPs that they assessed and whether those were categorized as high, medium, or low potential. They also looked at source control BMPs and found that those BMPs that separate the source from the stormwater are high potential for 6-PPD removal as well. So those include like street sweeping, catch basin cleaning, and maintaining roadside ditches. You're getting that 6-PPD, those tire wear particles, out of conveyance systems. So therefore, good form of source control for 6-PPDQ. Ecology is also funding 20-some BMP effectiveness research projects in Washington State. And I've added a link to their website. You can find quality assurance project plans. You can access study findings. Many of these research projects deal with 6PPDQ removal of commonly used BMPs. So talking generally about ecology and EPA response, we've got standard test methods being developed for soil and water. So in order to create scientifically credible and reproducible data, you have to have a standard test method. So that was one of the first things that needed to happen. EPA has done that. Ecology has developed some sediment standard operating procedures for processing those samples in the lab. Washington has created a water quality standard for 6PPDQ, and EPA has created a screening value. They've also been modifying their stormwater permits. NPDES permits that have been reissued recently include tire wear related requirements, which include like street sweeping and increased or reduced triggers for treatment on transportation related projects. We've also got EPA and ecology, like I said, funding BMP effectiveness, but also looking to address some of the additional data gaps related to 6PPDQ, like fate and transport. Where does this stuff go and when does it finally break down? We have a source control, slowly but surely source control effort, which is taking this chemical out of tires. Washington, California, are working with the U.S. Tire Manufacturers Association to look at replacing 6PPD with a different chemical, but it needs to provide the same level of safety, so it's going to be a lengthy process. So we have, I'm going to switch now to the federal ESA response, and this is Endangered Species Act. This is triggered on projects that have a federal nexus. Federal funding, federal permitting, or on federal land. And what we're seeing right now is because of this research, National Marine Fisheries Service is saying that any discharge of stormwater from a project is a potential to affect listed species. So right now, the top here on this graphic shows that ESA consultations, formal ESA consultations for any project that discharges stormwater is going to take 5 years approximately, which means you can't complete NEPA until that is over. So what National Marine Fisheries and Federal Highway Administration and WSDOT are doing is working on a programmatic. This programmatic biological opinion is based off of WSDOT's existing biological opinion that has streamlined their consultation process for many years. But this is going to apply to local jurisdictions for the first time as well. So this is just a snapshot of WSDOT's current programmatic. And based on National Marine Fisheries, this is not stringent enough. So what they're seeing in these negotiations is that NMFS is wanting WSDOT and others to treat all new and replaced PGIS if you have 500 square feet or more of impervious surface. So National Marine Fisheries is pushing currently for more stringent 150% of new and replaced PGIS, but WSDOT and Federal Highways are kind of pushing back on that. So currently, this is where we stand. This is what the new programmatic for local jurisdictions is probably going to include. And it's definitely a shift and an increase, but the benefits will be the shortened timeline. So instead of completing ESA in 5 years, it'll be 3 years. So it also standardizes the requirements. People will know as they go into this programmatic use that they have these treatment triggers that are going to be required and what their project needs to comply with. So I have been lucky enough at Jacobs and based on my time at WSDOT to kind of very closely track 6PPDQ, BMP effectiveness, what's the latest technologies, and been part of this whole permitting process and helping projects navigate through what do we do until this programmatic comes up. Once we have a programmatic, what do we do? How do we design our projects in order to be part of that programmatic? So with that, I'm going to turn it over briefly to Jeff Dreyer to talk about WSDOT's response.
Thank you. Yeah, when 6PPD came out, before that we'd been just cruising along. Consultations were predictable. We knew what the outcomes would be in most cases. Effect determination guidance was pretty standardized. And then it came out and the cities and counties started facing every single project they had that resulted in new pollution generating impervious surface overnight became adverse effects and individual consultations. So what they thought was going to be informal consultation became formal, which greatly increased the consultation timelines, and their project delivery schedules were greatly affected. WSDOT saw this happening, and we decided we had to do something quickly. And FHWA also recognized this, and we worked very closely with them. And this is where the collaboration came. National Marine Fisheries Service saw this too. They saw all these projects out in the cities and counties that were suddenly turned formal, and they saw a lot of projects coming in, huge delays in consultation timelines, and so they were eager to get with us to reinitiate our existing programmatic and include the cities and counties, which would greatly streamline all the consultations coming in. So instead of a 2 to 5 year consultation period for a project, it was now going to be coming down to like 2 to 4 months. It would be done. So the programmatic greatly streamlines this process. And I believe that, and we're still working with National Marine Fisheries Service in negotiating some aspects of this programmatic, but I don't see a big difference from what we're doing now. From our talks. So it looks like not a great deal that we have to do other than train our biologists and consultants in the new procedures and the new guidance for stormwater. So for ESA consultations, we've collaborated with the services. Some of the things that are still unknown now and are kind of inconsistent is actually the different offices within National Fisheries Service. So in Eastern Washington, Western Washington, they don't agree on some of these ESA effect determination changes. Also, U.S. Fish and Wildlife Service, who administers bull trout throughout the state, doesn't agree with National Fisheries Service approach. So there's still a lot of things that have to be worked out, but I think we're on the same page in terms of the programmatic because it benefits everybody.
Thank you, Jeff. Any questions? I have so many questions, but I will try to not bring them all to you. Within this, research showing that the chemicals being bound up in the soil, is there any concern with groundwater contamination and filtration practices?
Yes, but that is deemed the most efficient and effective treatment from a surface water standpoint. So infiltration and dispersion are the primary and best BMP that you could be using. In my opinion, bioretention, that you can actually catch the pollutant and then replace it, swap that material out, is likely a more sustainable approach rather than just pumping it all into the groundwater. But it's something, this is still December 2020 is when 6PPDQ was identified. So this is like a baby in stormwater terms as far as knowledge about these chemicals. Like I said, fate and transport is still a huge data gap. So the more we know, I think you'll see that the process for removal and the preferred BMPs may shift a little bit.
Well, that answers the second question. So
oh, good.
Any other questions? Should we let you guys more?
If no one else can ask, I got several.
Like I got to, one more of it. First, great presentation today.
Thank you.
So the first one is why Contaminant? And not the other salons.
That is a great question, and I cannot answer that. So there are very, very intelligent biologists that spend their entire career working on that. Jen McIntyre at the Washington State University Puyallup Extension has done extensive research on fish. Her whole research team is looking at what happens to the fish when they're exposed. And it's not just adult coho. They're the ones that were found in the streams. But since that time, Jen and her team and others across the world have exposed fish of varying life stages to 6-PPDQ. And in layman's terms, it messes them up. So they grow deformed and their heart sacs are too big and their brains are weird. Sorry. Yes, very technical, but they just do not grow right. So it's not just the coho, the adult coho salmon. It's affecting fish at all life stages. They can't really pinpoint at this point what it is, specifically why coho are most affected, but chum, who are also a salmon, aren't affected at all. So it's one of life's mysteries.
So my second question is probably you can't answer it. You indicate changing industry practices. Obviously, as the map gets larger and the effects are better known, that might include additional pressure. But what initially are we seeing as far as the industry's willingness to look at these issues?
Great question. That comes down to kind of the source control topic. And tire manufacturers, right when this research was published, said, hey, our tires aren't toxic. We've been following the EPA requirements for tire toxicity testing, and we're not killing the species that are identified in this toxicity testing. So they have actually been very responsive, in my opinion, to say we need to start looking at other alternatives. But again, they have to find something that provides that equal level of protection for tires. We can't have tires that degrade in a year and everyone's replacing their tires all the time. And those other chemicals may create their own environmental problems. So it's going to be a very lengthy process to try to figure out what is a good chemical that can provide that safety and not provide that environmental degradation.
All right, let's say we have time for one more question. 30 seconds. Good.
And any of you can come. I'll be around today and tomorrow, so please feel free to come chat.
Do you know if any of the QPP is being preserved in behind dams and settings and stuff? So you go out there and remove the dam because they're going to show that it's in really high concentrations?
It's a great question, and as I mentioned, that fate and transport is still a data gap that we don't really know a lot about, but likely those tire wear particles continue to be a source until all the 6-PPD is gone, and they don't really know how long that takes. So anytime you have tire particles sitting in a ditch behind a dam, there is potential that that particle is going to continue to be a source for some period of time.